Hello everyone. So today we'll be solving this LeetCode medium problem, largest divisible subset. So the problem states that we are given an array of positive integers and we need to return its largest subset such that every pair of elements in that subset will satisfy this condition. Means either the first element in that pair will be dividing the second pair or the second pair will be dividing the first pair. So, and if like there are multiple solutions possible of that largest subset, then we can return any of them. So for example, if we have this case here, so if we choose subset as 1, 2, then we know like if we pick any two pairs of I comma j, so here 2% 1 is equals to 0, right? Or if we pick like 1, 3, then we know that 3% 1 is equals to 0. Now if we pick like suppose 2, 3, then here 2% 3 is also not equals to 0 and 3% 2 is also not equals to 0. Hence this will not be a valid subset. Now let's pick, so this cannot be a valid. So we have accounted all like, and if we pick a single element, then obviously this means condition will be satisfied. So we need to return the means largest subset which is possible. So first we need to like find out the maximum size of the subset that is possible, and then we need to construct the answer as well. So here means the answer was 1 2, it can also be 1 3 as well. Okay, now let's see a given means a different input. So here we have 1 2 4 8. So as we can see, like here, since the numbers are in increasing order, so we know that suppose there are three numbers a less than b less than c, and if b% a is equals to 0 and c% b is equals to 0, then this means that c will be divisible by a as well, right? This will be true. Hence we now know like if the numbers are given in an increasing order, then obviously this smaller number can only be a means a divisor of the bigger number. This bigger number can never be a means divisor of the small number. Hence this gives us an intuition like we means when we are given the input, first we can sort the input so that we get the input in a sorted order, and then we pick elements in this manner such that this element will divide the next element, and then this next element should divide the next element, and so on, right? And then we try to find the means longest sequence possible, right? So this is what we'll do. So suppose here the input was already sorted. So for 1 we started. Now we picked 2. Multiple of 1 was 2. Now we picked multiple of 2, which was 4. Again we picked multiple of 4. So multiple of 4 was present, so it was 8. So we see like 8% 4 is 8 is divisible by 4, 4 is divisible by 2, and 2 is divisible by 1. So all pairs possible are divisible, because since 4 is divisible by 2 and 2 is divisible by 1, hence it implies that 4 will be divisible by 1 also. And similarly, since 4 is divisible by 2 and 8 is divisible by 4, hence 8 will be divisible by 2 itself. So we'll use this property here and try to like sort the input. And once we have the sorted input, what we'll try to do is we start from any element and we try to go till the largest segment such that we get the multiples of the next element. For example, we are able to find the multiple of 2 on the right. So this 4. If we have like picked 8, then the subset would have looked like this. This is also a valid subset, right? 1 4 8, this is also valid, right? But since we need to maximize means the size of the subset, so this will be the valid output here. So as we can see, like if you have solved any similar problems or involving like longest, if you have solved this problem, longest increasing subsequence, so if you have not solved it, you can like after you watch this video, you can try to solve this problem as well. So what we need to means do in this question is we just need to find the longest subsequence which satisfies this condition only. Means a less than b less than c less than d and so on. We just need to satisfy this condition. But here we have an extra condition that b% a should be equals to 0, then c% b should be equals to 0, and so on, right? So the condition means that we need to find means the solution that we'll get will be a subset of LIS only, right? means LIS will have suppose 1 2 3 4 5 6 so on, right? But but this condition that we require will only have elements suppose 1 2 then 4, or 1 2 then 6, right? Or 1 3 then 6. So these are like subsets of this LIS that we get. So this gives an idea, like if we are the approach that we use to solve the problem longest increasing subsequence, maybe we can maybe we can modify that approach a bit to get the solution for this problem. And now how do we solve the problem of longest increasing subsequence? We solve it using dynamic programming, right? I hope you are aware about how we get the longest increasing subsequence. If you are not, then it is simply a 2D DP where we maintain the DP of current index and the last index, and we simply keep updating it. If we when we encounter a new element, we will see if nums of index is greater than nums of last, then we'll pick this element or skip. So we'll pick or skip an element using DP, and finally return the maximum length possible. So this is what we do in normal 2D DP to find the longest increasing subsequence. As you can see, we just not need to find the longest subsequence. We also need to return that subset as well, right? So here when we sort the input, that this subset will become a subsequence, right? Because if the input is sorted, then we just need to find an increasing subsequence which satisfies the condition, right? So condition of this should be a multiple of this, then the next element should be a multiple of this, and so on. So I hope you are now able to get the logic of what we need to get here, and how we are relating this problem with longest increasing subsequence. Now we can also, once we have this solution, we can also one way of solving this is using 2D DP, or we can use it means solve it using a single vector DP as well. So I'll be showing you the single vector solution of DP, and then we'll see how we'll be manipulating that to get the answer for our current problem. So what is the steps that we need to follow? We first need to this DP that we had will only help us to get the longest, means length, okay? But here once we are able to find the size of this maximum length, then we also need to construct that maximum length, right? The construct the subset which is making that maximum length. So these are the two steps that we need to follow. So what we'll do, suppose let's derive the solution for step 1 first. Step 1. So we need to suppose we initialize the DP as DP of I, where DP of I denotes the maximum length subsequence that we can get, maximum length subsequence ending at index I, ending at index I. Okay, so we define DP as this. Now how will the base cases look like? So for one length subsequence, means DP of 0, DP of 1, and till DP of n minus 1. Initially these all values will be 1 only, right? Now we need to update it. So initially for DP of 0, it will be 1. It is fixed. It cannot be greater than 1, right? Now we need to calculate further DP values using the previous DP values that we have already calculated. So what we'll do all possible ways of, since we need to find the maximum length subsequence that ends at I, so we'll check for all possible values of j which are less than I, means 0 to less than I. Okay, and we'll see, and if this nums of I is divisible by nums of j, then we'll update our DP and see how we'll be going to update it. So what we'll do is, since for DP of 0 we have already found out the answer, now let's start with DP of 1. Okay, so we start with the first index. Okay, now what do we want? We want to account all the possibilities of, means the last values that we can get, and the last value we can get is from 0 till I minus 1, right? Means suppose we had the subsequence 1 2 4 and the array was 1 2 3 4. So if we want to find the dp value of this, then we need to account all possibilities of previous values, suppose, right? And since here this 4 means 4 is divisible by 2, so hence this dp of at this index will be dp of 2 plus 1, means the dp calculated till this point plus one more length we are able to get. So this is what we'll do for each j from 0 till I minus 1, right? So I hope if you are like aware about the longest increasing subsequence solution before, then this will be like, this will seem very simpler to you. But if you are appearing means solving this for the first time, then just try to understand the concept, and once you will use it to solve means many problems, then it will become simple only. So this is how we like generally calculate. Either we can also use the 2D DP that I discussed, or since I need to like construct the answer as well, that's why I am not discussing the 2D DP approach, because then the video will be very long. So I am constructing the DP currently to find out the length, and then we will later construct the answer as well. So what do we need to know? We need to a loop from j for j from 0 till I minus 1 to account means the last value means before I. Okay, so this is what we need to do. Now what do we need to check? We need to check if the means the last value that we have at jth index and current value we have at ith index. So we need to see like whether nums of I is divisible by nums of j or not, right? If it is divisible by nums of j, then the dp value that we means the maximum length subsequence that we get ending at index j, so we can just simply reuse that value to get dp of I as 1 plus dp of j. Okay, so this is what we need to do. We need to check if means nums of I percent nums of j is equals to 0. Then we check means if 1 plus dp of j, okay, and if it is greater than current dp of I that we have, then we will simply update current dp of I. Okay, and once we have updated it, we will simply end this loop, and once this loop is ended, we may like maintain a maxi variable where maxi is initially 1, and we can update maxi with maxi equals to max of maxi comma dp of I. Okay, once the value for dp of I is calculated, then we can simply update our maxi and finally return maxi. So if the problem had been like find the largest means length or means size of the largest subset which satisfies the condition, then our problem would have been done here only. Okay, this is what we needed to do. But here we also need to return that largest subset. So the next step is to construct that subset. So now how do we construct the subset based on the means the DP calculations that we are doing? So we know like once we are at a particular index, right? If this DP value is getting updated, then that means we can like maintain a means parent kind of thing. Parent kind of thing, how we can maintain, like suppose we have this array, and if we know like, so here we know like before I the previous value will be at index j. So if I maintain the indexes, like before this I there was j, then before this j there was some index j1, then before this there was some index j2, and this is how the dp value got constructed, and we got the answer as 4, suppose say. So then we'll be able to simply use these indexes to find out the final subset will be nums of j2, then nums of j1, nums of j, and nums of I. So then this will be the simply the subset answer that we need to construct, right? So if we somehow maintain like from which index the maximum value is coming at current index, then we'll be able to simply traverse back and find out the result, means construct the result, complete result. So this is what we'll do. So initially at dp of 0, we, so initially how do we construct? So let's maintain a parent kind of thing. Suppose we have a vector parent, okay, of size n only. Now initially all the parents are initialized as -1, okay, and dp of 0 was 1. Now when we are at a particular index, suppose I, and we came from j, that means if 1 plus dp of j was greater than dp of I, then that means the parent of I, means the previous element before I, was this j. So we can simply like write one line of code here, that parent of I will be j, okay, and yeah, we are done. We just needed to do that, and we also need to know like at which index, h index, a maximum subsequence ends. We also need to maintain this so that we start from that I. We should be aware of this I, so that we start traversing in the prev vector for this I, and then keep moving till we are able to move back, means till this value does not becomes -1, then till then we will move and construct our result. So I hope the overall logic is clear. We just needed to add this logic of when the DP is getting updated, that means the previous element before ith index was j. So we'll maintain this parent vector and mark parent of I as j. And using this, we'll be simply able to solve the problem, and then after that we'll means write the code for constructing this subset. So let's see the overall code and see, means I hope like then you will be able to get it. So initially we are sorting the nums, so that instead of subset we can simply find the subsequence in the array. Okay, I hope this logic was clear initially. Now we denote dp of n means initialize with 1, because initially means one length element will be having the answer as 1 only. Okay, and initialize prev, this prev is simply the parent array, okay, and prev of n as -1, because no previous elements exist for any element before. Now initialize with maxi variable to store the final, means the max length that we can get, and this end to find out the I, means to find out the I at from which we will start to get the maximum length subsequence. To get this maxi length subsequence, we will start from this I, which is denoted as end here, and then we'll keep moving back till we encounter like prev of j equals to -1. Then we will simply stop there. Okay, this is what we'll do. So we do the same. We check if nums of I percent nums of j is equals to 0, means the previous element divides the current element, as well as 1 plus dp of j is greater, means we are getting a greater length. Then we'll update the dp and mark the prev of I as j. Okay, and to find the end, means to keep calculating this end value, we see like if dp of I is greater than maxi, then we get a new end. So we'll mark end as I here. Okay, and now we need to reconstruct this answer. So how we'll reconstruct? We'll simply like suppose create a vector int result. Okay, now we need to reconstruct. We have the end index and we need to move back some steps till we do not encounter a -1 value. So that means this result should have a value, nums of end initially, which will be present at the end. Now we need to move back. So we'll do this while this prev of j is not equals to -1, means while this prev of end is not equals to -1, and we'll keep moving this end to prev of end, and we'll keep doing this till we encounter. So this is what we'll do. We push the result, means for the end index this number will already be part of the result subset. So we push it in the vector, and then we mark, means keep iterating a loop till we do not encounter a -1 value. Okay, and we mark the end as prev of end and push the result, and the final, means this will store the result in form of like nums of end, then the previous value, and then the previous value, nums of suppose j1, then j2, and so on. So this will be in the reverse order, right? So we need to finally reverse the array to get the solution in the sort, means a particular order, a sorted order. Okay, so this was the mean solution for this problem, and as we can see, the time complexity would be of the order of n square because of the two loops being used here, and yeah, space is big of n only. And since the constraints were till 1000, so from that this also we can get the idea, like we can apply dp here or 2d dp here, and the answer construction also we can do in multiple possible ways, and this was one of the possible ways of doing it. So I hope like you were able to like you will be now able to solve this. If you have not before, we will be able to solve this longest increasing subsequence problem on your own. We here what we'll need to do, we just need to remove this condition and see if nums of j, nums of I is greater than nums of j. This is a single line change that we need to do, and we'll be able to solve the problem longest increasing subsequence, and we will be able to construct this as well using the prev if we are required. So I hope let's try to submit the code as well here and see how well it performs. So as you can see, like it runs in 4ms, which is very fast because of big of n square complexity, which is go up to 1e6 only. So I hope you are now like aware about how we will be using, means instead of using 2d dp, we can just simply use a single dp if means if we are like able to go through all the possibilities without requiring that second dp state. Okay, and then using this algorithm we can, like using this parent or prev array, we can simply reconstruct the answer as well. So this was the means the overall logic and approach for this problem, and try, I hope like you should try to like solve similar problems on your own, like using the same logic you will be able to solve similar problems as well. So that will give you confidence as well to like handle these kind of problems. So I hope all your doubts are clear, and if you have any doubts yet, feel free to comment down and I will be happy to help. Thank you for watching.